This question was asked in one of the sample papers. This is an AoD case study question based on maximize and minimize, which is optimization problem. In an elliptical sport field, the authority wants to design a rectangular soccer field with maximum possible area. The sport field is given by the graph of x square by a square plus y square by b square is equal to 1. If the length and breadth of the rectangular field are 2x and 2y respectively, then find the area of the function in terms of x. Find the area function in terms of x. Okay, so there are four subdivisions. The graph of the ellipse is given and the equation of ellipse is given. And there are four subdivisions here. So first subdivision, second subdivision, third one, and fourth one. They're asking us to maximize the area of the rectangle. So I tried drawing the rectangle such that it is inscribed inside this ellipse as shown in the diagram here also. So they're also saying that we need to assume the length as 2x and the breadth as 2y, then the area, find the area function in terms of x. So in general, what is the area of a rectangle? That would be length into breadth. But they're asking us to assume the whole of this length to be 2x and the whole of this breadth to be 2y, correct? So this would be 2x into 2y. Now, if you take this one as the origin, this length would be x, correct? And this length would be y. So this point here becomes x comma y. So area would be equal to 4xy, and we need to change y in terms of x. That's what they're asking. Find the area in terms of just x. So we're using the equation of the ellipse, x square plus y square, or x square by a square plus y square by b square, that is equal to 1. Now we need to rewrite y in terms of x. So I'm going to write this as y square by b square is equal to 1 minus x square by a square. Now, in place of y, we can substitute area is equal to 4x in place of y. So we still need to solve this. So y square is equal to b square into 1 minus x square by a square. So y square would be equal to b squared by a square. So a square minus x square, correct? So that would be 4x into b by a. So if you take square root on both sides, it becomes b by a times of root of a square minus x square. So this is the required area in terms of just x. So if you can see, there is no y term involved. So there is just x here, okay? So the second subdivision would be find the critical point of the function. So for solving this, we need to differentiate the function and equate it to 0. This is area function, and we need to differentiate f dash of x is equal to 0. So that would be here 4b by a. They're all constant. So f dash of x would be equal to, I'm keeping 4b by a constant outside. So it can be differentiated using UV differentiation rules. So I'm writing it here. Four b divided by a into x into, if you differentiate this part, it becomes 1 divided by 2 times of root of a square minus x square into, if you differentiate the term inside, it becomes minus 2x. And vu dash would be root of a square minus x square into x would be just 1 and equate it to 0. Now this becomes minus x square divided by root of a square minus x square, because the 2 and 2 would get cancelled. X and minus x would become minus x square divided by root of a square minus x square plus a square minus x square is equal to 0. So if you transpose the terms, you will get x square is equal to a square minus x square. So it becomes 2x square is equal to a square. So x square would be a square by 2. So x would be equal to a divided by root 2. They're asking us to find critical point, find the critical point of the function. So x equals minus a by root 2 would not be applicable because x here denotes a length. It's half the length, right? So it's a distance. Distance cannot be negative. So x here is minus a by root 2 is not possible, right? So the only possible x value would be a by root 2. This is the only critical point, and this is the answer to the second subdivision. For the third subdivision, use derivative, the first derivative test to find the length 2x and width 2y of the soccer field that would maximize the area. So if x is equal to a by root 2, so we already had an expression for y in terms of a and x. If we substitute it here, so y square is equal to this, y would be equal to b by a into a square minus x square. A square minus x square would be a square by 2. So this would be a square divided by 2. So here it becomes y is equal to b by a times of a square minus a square by 2. So this would be a square by 2. And I think it should have been under square root, correct? This should have been under square root. So root of a square minus a square by 2. So that would be just root of, this is a square by 2. So it becomes a by root of a by root of 2. So what happens to, this would have been root of a square rather. So a square and a, root of a square and a gets cancelled. So y also becomes, actually x is a by root 2, y is b by root 2. So we have the answer for y. Now, they're asking us to find out 2x and 2y, which is the length and the breadth, because the length, if you remember, it was 2x. So that would be 2 times of a by root 2. So that would be root 2 into a, and the breadth would be, the width would be 2y, which is equal to root 2 into b. So these are the required answers for the third subdivision. For the fourth subdivision, use second derivative test to find the length 2x and width 2y of the soccer field. So we need to ensure the second derivative test should be used very carefully, okay? Unless otherwise they ask in the exam, you don't have to solve for second derivative test. But in this question, they've asked for second derivative test, which means we use this to verify whether the critical points we have found out, that gives you the maximum area. So we need to find f double dash of x and substitute the found out x value and check whether it gives a positive value or a negative value. So if f double dash gives you a negative value, then that ensures that we have a maximum value at that particular x critical point. Okay. So the question asked is, use second derivative test to find length 2x and width 2y that maximizes its area. So we already have found out what is f dash of x. So we need to take that and differentiate it again. So f double dash of x would be equal to this 4b by a would be as it is. And this term needs to be differentiated again. So before that, we'll try to simplify it. So 4b by a, this into, I'm taking LCM here. So this would be root of the whole root of a square minus x square. And on top of it, we have minus x square plus a square minus x square. So This would be minus 2x square plus a square. Okay. Right. So 4b by a, this is u by v differentiation. So the denominator would become a square minus x square without the square root, and vu dash would become minus 4x plus uv dash. So minus 2x square plus a square, the whole into 1 divided by 2 root of a square minus x square, and on top of it we have minus 2x divided by this. Okay, so 4b by a, and this one becomes minus 4x into root of, can we take LCM here again? So it becomes a square minus x square into minus 4x, and then minus 2x into minus 2x square plus a square. This whole root of a square minus x square gets pushed to the denominator, so it becomes a square minus x square into root of a square minus x square, which makes it 3 by 2. Because if you multiply a into root a, it can be written as a 3 by 2, a power 3 by 2. So this root of a square minus x square gets pushed downwards. That is after taking LCM on the numerator. So now I'm going to substitute f double dash of, in place of x, I'm going to substitute a by root 2. So here it would be 4b by a, and in place of x, it should be a square by 2. So a square minus a square by 2 into minus 4a by root 2 minus 2 into a by root 2 times of a square minus 2x square. So x square is a square by 2. So 2x square would be just a square, and these two terms gets cancelled. They get cancelled. So that divided by a square minus x square. X square is a square by 2, the whole power 3 by 2. So you don't have to calculate it. We just have to check which terms are positive and which terms are negative. So this term is positive. 4b by a is positive. A square minus a square by 2 is positive. And this term is a negative term. And this term has to be zeroed. And the whole divided by a square minus a square by 2 is also positive. So it has to be power 3 by 2. So we have positive into negative by positive. So the answer is overall negative. So what we have found out from here, when x is equal to a by root 2, we have found out that the second derivative f double dash of x is negative. So that indicates at x equal to a by root 2, we have the maximum possible area. From here on, we can substitute and find out what are 2x, just like in the previous question. 2x would be the length, 2x would be equal to root 2 of a, and the breadth 2y is equal to root 2 of b. The same procedure as the previous question can be followed after this, but this question is slightly bigger than the previous questions. That is because it involves a lot of u by v differentiations and simplifying the terms. And finally, you don't have to find the value. You just have to substitute x equal to a by root 2 and just check whether it is negative or positive. If you get f double dash of x to be negative, you will get maximum area at that particular x value. Okay. So we have answered all 4 questions. That's it.